Hey, what up, Anthony?
How's it going, Drew?
Pretty good. So I hear John has been kind of leaking some information about a project I've been working on, which is not so private anymore because I recently open sourced it. But I hear you're wanting to know about the Git Patch Stack.
Yeah, he was explaining to me he's got a new flow that he's been using that you created and sounded pretty interesting. So I want to get a bit of a rundown on the whole thing.
Sure. Yeah, yeah. So let's start with, I guess, the Git repo. So I put it up in uptech git-ps. It's a so basically it's a methodology and a Git workflow, but I've also built a small command line tool around it that's a extension to Git. And that's why it's called git-ps, is because if you make a command line tool with that naming scheme, then Git sees it as an extension and lets you interact with it using it as a subcommand inside of Git.
Oh,
So
I didn't know that.
yeah. So the subcommand for this is ps for patch stack. So the common usage is like you would do git ps and you could do like dash dash version and it spits out the version. Um, but so it's like the subcommand is just ps for patch stack.
Right, gotcha.
Um, so do you know about patches?
Very little. I haven't really dug deep into much of any of this stuff.
Okay, so patches come from like Unix basically. Um, and patches, like the diff command on Unix, lets you take two different files and just get a diff of them. And the output of that is a special format, which is called a patch format. And then there's another command line tool in Unix called apply, that allows you to take a diff patch, which is just a text file in that special diff format, and apply it somewhere else, right? So you could create a diff, you could share that diff over the internet by sending it via email or wherever, or sharing it online in message boards or whatever, and then you could apply it, right? And that's how a lot of the open source stuff was done back in the day. Um, in Git, they provide tooling native to just the Git command line tools to actually create patches as well, and that's called Git format patch. And the kernel team, Linus, who invented Git, he heads up the Linux kernel team, and they use a flow that still uses patches today. But they use the tooling built into Git to utilize those patches. And so they have basically a command line tool that generates a patch off of Git, and then that patch is sent to a mailing list, and that mailing list is usually a mailing list specific to that segment of the Linux kernel. And then anybody on that mailing list can chime in and review that diff, basically. So that's their peer review process, is using email and mailing lists. So
Wow, that's a interesting flow there.
yeah. And so like people comment on their emails and then they make changes to their Git commits locally, and then they produce a new patch and send the updated patch to the mailing list, and rinse and repeat until it gets accepted, right? Once it's accepted, the integrators on the kernel teams take it and actually apply that patch to their local Git managed repositories, and then eventually it gets pulled in from theirs into upstream earlier on. Um, but yeah, so it's interesting. There's a few interesting things about it that I liked. So like patches are free; they're not coupled. So it's literally just a text file that has no concept of hierarchy. Like it doesn't know what its parent is. It doesn't know what associations it has to anything. It's literally just like a snippet of code that can be reviewed independent of everything else, right?
hmm
Um, and so I personally, in all of the Git flows that I the Git workflows I've tried to use have struggled with this tension because there's like these best practices where you're supposed to have like small commits and small pull requests. Um, but I always felt like there's this weird tension where I couldn't make small pull requests and still follow, like good feature branch workflow, without ending up creating like branches that depend on branches that depend on branches that depend on branches. And then when that lowest branch, needs a change, then I have to rebase all of those branches on top of each other, and it becomes this huge amount of work just to
Right.
maintain that stuff. Um, I mean, so what I see most people doing is they just kind of throw out the best practices, and they're like, well, we don't need to, make small pull requests because it's too much of a pain in the ass to actually do it and maintain the branch structures. So Git Patch Stack is the workflow I built around this concept of patches. In reality, it's not actually using patches, and we'll get into that, I guess. But conceptually, your workflow is patch driven. Um, and the idea is that there's no feature branches anymore. And you basically create a stack. And it's not a stack in terms of like computer science stack, it's just like a stack of paper. You can reorder things, you can do all the kinds of things you could do with a stack of paper, right?
Right.
Except you have patches, and each conceptual patch is a logical unit that should be buildable, testable, and make sense as a logical unit. And each logical unit, which is a patch, should be is what is submitted for review from peers. Um, so each little thing is kind of individually a piece, and the way that you think about things is a little bit different because you're not thinking in terms of I put together a whole giant feature. You're thinking about what kind of the kernel team talks about because they require patches. They talk about like kind of a proof of work, right? So when you're making like a big change, like let's say it's like 8 patches in reality that it requires to get to that thing, but you still have 8 individual logical patches that have to be applied in a sequence to get to that end resultant state. And the way the kernel team looks at those individual patches is that the descriptions around those is super valuable, and it's like proof, like it's your proof of work, like when you were a kid in school and you have to do math, and the teacher's like, cool, here's the answer, you write it down, and she's like, no, you got to show me how you got the answer, right? So I agree with the kernel team. I think there's value in seeing that proof of work and understanding the progression of how features go, and having that history baked into your Git tree gives you a lot of value in terms of like going back and fixing things, or like if you run into a problem and you want to revert something, it makes it really easy to go back and find something and revert something. Or it also gives you the benefit when you follow these rules that you can use high-powered tools like Git Bisect, if you're familiar with that. Um, but it's like a tool that basically does a divide and conquer algorithm against your Git tree to identify an individual commit that a bug was introduced in, right?
Mm-hmm.
And so it does it for you, right? But that only works if you make sure that each of your commits is buildable and testable, right?
Right.
So yeah. So that's the gist of kind of why I came up with it, is I'm trying to solve all of those problems. And I think I have, at least for me and the other few developers that are using it right now. Um, it seems like everybody's super happy with it. I originally built like a bash script version of this, and then had there were some limitations in the bash version, where I wasn't doing any state tracking and management to make things nicer, and so then I decided, all right, well, I'll rewrite a version of it in Swift so I can get the state management stuff implemented. And then it also gives me the functionality and the flexibility to, if we decide to make it into a graphical user interface in the future, it's an easier transition to do so.
Right. Yeah. Gives you a little more flexibility later on.
Yeah. So here's all the commands that exist in Git Patch Stack. So there's basically Git Patch Stack ls, which shows you your current stack of patches. There's Git show, and you give it a patch index, and that just shows you, it's like Git show, but it just makes it easier to reference a patch. There's Git pull, which fetches the state of origin master and then rebases your stack of patches onto it. And then, which is also just kind of a convenience method. Then there's Git rebase, which does an interactive rebase of your stack of patches. Also,
Right.
just
on top, I guess.
Yeah, on top of origin master.
Yeah.
And so the way you can think of your stack of patches. So like right now, if we look at this Git tree, like there's master and origin master right here, and my stack of patches is 0. I have no patches on the stack, right?
Mm-hmm.
So if I was to add a commit right now, because you work directly on master, we would have 1 patch on the stack, right? And then so on and so forth. So it's basically like your stack of patches is the commits that are on top of origin master and under master as the head.
Right.
So, and then we have RR, which is request review. So basically you can say, cool, Git patch stack request review for this particular patch. And what that does is a bunch of stuff behind the scenes to make all of this happen. But it basically tags the commit that is that patch with a unique patch identifier, and then stores state around a branch that it creates for that and publishes that branch up to origin, and then lets you create a pull request off of that. So one of the things that I didn't like about how, or that I felt was kind of weak about how the Linux kernel team does all of their stuff, is that it requires that you use kind of this old school patches concept in terms of peer reviews and use email for managing peer reviews. And there's been a lot of work and energy that's been put into building good peer review experiences in GitHub, in Bitbucket, in all of these other tools, right? And all of those tools are built around this like branch concept and having feature branches basically. And so what I'm trying to do with Git Patch Stack is bridge that gap, right? I want to say you can work locally with a patch concept and a stack of patches, and that has a lot of power and flexibility that it unlocks for you and benefits. But in terms of the peer review experience, you can still, effectively on the other end, nobody knows that you're actually using Git Patch Stack locally. They just see a branch with a pull request and they review it the same way, right?
Yeah.
And then the last command is publish or pub. So there's Git Patch Stack pub, and you say publish, and then you give it a patch index, and that publishes a patch into upstream's mainline, aka origin master, right? And so that's like the normal flow would be like you make a commit, it gets added to your stack of patches. You can, make more commits and rebase and edit them and reorder them and do all of that stuff until you finally have one that's in a good state. And then once you have one that is in a good state and you want to request review of it, you do a git psrr with that patch index. That creates, you go through that, create the pull request, and then you move forward, right? And eventually somebody reviews that, and then once they review that, you can actually publish it, right? So you do a git ps pub. But one of the beauties of this whole thing that you don't have to deal with is that with branches, like let's say I was going to add, sub feature A, like I'd create a branch for that. And then while I'm waiting on that to be reviewed, I would go try to create B. But I have this tension where I'm like, shit, I got to get that feature A branch reviewed as quickly as possible and merged into master so that I don't have to deal with this branch on branch action, right?
I'm always fighting that.
Right? So this prevents that completely. You don't ever think about that anymore. In fact, the beauty is you almost don't care how long it takes somebody to review one of your features, one of your peer reviews that you put up. Because it's just sitting, it's a change that is sitting in your stack of patches. So you just keep building your stack of patches, and as you make changes, you just keep building on top of the changes you made before, whether they're approved or not. And then once, let's say somebody comes back with feedback, that's cool. You just go make changes to that patch to address that feedback, and then you submit it back. You request review of it again to update the PR.
Right. So basically, the request review will also create a pull request on GitHub or Bitbucket, so you don't even have to deal with the web interface, right?
So right now, it doesn't actually integrate directly. It just integrates via Git. It doesn't integrate with the APIs with Bitbucket or GitHub. It just dumps the URL out to create the pull request initially. Once the pull request is initially created, if you want to update it, you just run git psrr and that patch, and it'll update it without you having to do anything in the web interface. But the first time you create the pull request right now, it requires you to click the link to go create the pull request. That's one feature.
God.
That's one feature that I would be very nice. One thing I thought about doing, which we haven't done yet, is we can grab that URL out of the output from the command, and instead of like dumping it to the screen and letting the user click on it, we could instead just open your browser for you, the default browser, to that URL, and it would streamline it a little bit. I don't know. If I do make this into a graphical user interface version of this, I definitely would do the integration with GitHub. I would just do the OAuth integration with GitHub and then automate the actual creation of the pull request. Because
it actually help a lot in the whole flow of everything too.
Yeah, and the other beauty of this is that the other like best practices and principles that this kind of supports is that each of your Git commit messages end up being super valuable, right? They're super clear in communicating what they do, why they did, like why you did what you did, and any contextual information about how that commit relates to other commits or any of that, which also results in super valuable pull request descriptions without you even trying. Because when you create a pull request from a single commit in GitHub, it takes the description out of that commit and slams it into the pull request description for you.
Oh, okay.
Yeah.
Gotcha.
So
basically, it uses both the title and description of a commit.
Correct.
As it never used to, really.
Yeah. Yeah, and normally what happens is, like in my experience, is most of the time people have a bunch of random commits, like in their branch, and then they submit this branch with a bunch of random commits that some of them are broken, some of them are not broken, some of them are in weird states, some of them could be whips, right? They have a branch full of all of these commits, and then they submit a pull request with all of that, right? And all that breaks functionality, right? Like if you merge that into your tree, like guess what? You can't use git bisect anymore, right? You lose all of that power and all that functionality just because the tooling and the tooling and the workflows that people have kind of adopted and become popular don't facilitate doing what Git was actually kind of intended to do and how it was intended to be used.
Right.
Because people just aren't following the best practices that are well known Git best practices. Because it's hard with the current workflows. So
So far, I'm liking what I'm hearing. Definitely something I want to start implementing and messing around with.
yeah,